Hello, my name is Levi Neely, and welcome to my capstone project about procedural generation. So, what is procedural generation? Procedural generation is a method in which an individual can create something utilizing some sort of formulaic approach. So in this case, I wanted to create a video game, but I do not have a ton of background in designing levels or creating art assets. So I wanted to utilize code in order to help to develop these things to make them still utilizable and interesting, but also something that I could create without having a ton of experience in that. And this is not only beneficial for an individual, a developer trying to make the game, it's also beneficial in the way that resources are utilized. And it's also beneficial for a user. It can develop a lot of really unexpected and unique ways that an individual may not have thought of. So, diving right into my project. I developed this project in the Godot 4 engine, utilizing GDScript, their own scripting language that they have for this engine. The reason I chose it, it's free, it's open source, and that also allows me to be able to develop, certain plugins or add-ons that I could utilize while I was creating this project. It also has excellent documentation, a lot of tutorials that made it really easy to learn on the fly. And there is no licensing or scaled pricing, which was particularly beneficial with Unity's recent change. Additionally, there's also a lot of people transferring over to Godot since Unity's downfall. So that's been a really big asset as well. There's a lot more projects that are being worked on in Godot. So jumping right into my project, I wanted to kind of dive into the different functionalities. So the first thing I had was a save load functionality, ensuring that the data is persistent across all the different versions of the player's game. So when a user starts a new game, all of that information that is used to generate all the levels and all of the data moving forward is saved within that save file, so that each time that they then come back and load a game, all of that data is persistent, so they're jumping into the same world that they left. But if they choose to go into a new game, then that's completely different, and that experience will be completely different for them. Now, I just wanted to kind of walk through the sort of game loop and what that looks like. There's a start screen, obviously, which leads to a loading screen. And this is in parentheses because that loading screen happens anytime that a scene is shifted, that we change in between the different values. And then there's the world map where the user spends most of their time. And this is where the terrain is generated. And from there, the player can go into dungeons. And from the dungeons, obviously, they could succeed and go back to the world map, but they also could die. So from there, they can respawn or go to the main menu. So jumping into the actual procedural generation, starting with terrain generation, the first that the user encounters. It starts by initializing noise objects, generating 4D open simplex noise, which we'll talk about a little bit more later. And then it places tiles based on those noise values. Then there is a grid of chunks that is created around the player that stores that data, and then that player position is tracked, and then more of those noise objects are used to generate the tiles that are around that new position. So what is open simplex noise? There is random static noise that you might remember seeing on random TV channels. And Perlin noise is a function that takes those random values, smooths out the values in between them, creating these gradients that allow for more biologically smooth patterns, or organically rather. Then later, the person who derived Perlin noise was able to implement it in a better way, improved on it in the simplex noise. But that was copyrighted, so open simplex noise was generated. Now, the problem that I faced is that the terrain that I wanted my world to have, I wanted it to be obviously in a 2D world, but I wanted the player to be able to travel in one direction and return to where they were, simulating being on a globe, on a planet. But in order to do this, you actually need to use four-dimensional noise so that those values can be mapped onto a sphere while being on a flat surface. But 4D open simplex noise is not something that is in the Godot engine natively, so I had to implement that by hand, which was a wonderfully fun experience. But this allowed for that functionality. This is again just kind of a diagram showing how chunk loading works. There's that player in the center, and they have these chunks around them, and as they move, those chunks are then removed or loaded again. And we'll see that implemented shortly. So this is the chunk loading demo. As the player is moving, those chunks are being offloaded if they are no longer needed, and new ones are being loaded. And all of that data is stored. Now, from here, we move into dungeon generation. The player can enter these dungeons. There are room shapes that are generated in these dungeons. Those shapes have collision devices that allow them to spread out, and then we call unfit rooms. Then we generate hallways, place the art assets on top of that, and then items and objects are placed inside of that. So here's kind of what a finalized dungeon in a previous version of the game looks like. And in order to connect all of these rooms, I utilize the A-star algorithm. Now, this is a lovely GIF that kind of shows how the A-star algorithm works. And it works by providing a heuristic to the algorithm, basically saying, are you closer or farther away from your end goal? And then it searches the graph that it's a part of to find the best ways to get to that point, and then returns that path at the end of it. So here's just kind of a short demo. You see the collision shapes. This is already after they have spread out and that the culling has happened. Then the assets are placed on top, walls, objects are placed in, and that's it. It's good to go. Now we'll get into a demonstration of the actual game. So there's the starting screen, a new screen, super basic dialogue, but here's the world. So you can already see those organic sort of curves and shapes that transition between the different biomes. Each tile utilizes 4 different 4D open simplex noise values, one representing altitude, one for temperature, moisture, and plant life. So based off of those 4 values determines whether it's going to be grass, part of a forest, or a desert, or sand, or a beach, or whatever. And then as we move through this, you can see there was that sort of lagging. I implemented that so that I could have a visual way to show when a new chunk is being loaded versus data that has already been stored. So as you can see, as the player is moving back on this, then it's a smoother load. Now we're going to enter the dungeon. Some more super basic dialogue. And you can see the rooms, they are connected, and they're more randomized. So each of these objects that are in the 4 corners, the sort of decorations, and the number of enemies, whether or not sort of the difficulty of the room is all randomly assigned. Based off of that difficulty value, gives a chance to drop a chest. So I actually ignore our end goal that's down there and try to go and find one of those chests. And this, on a gameplay standpoint, is to encourage people to interact with the level and look for those things. But it also shows that with procedural generation, there's a lot of different things that can be accomplished. So it's not simply just for, different art assets or level generation. It can help to tell a story or to vary the difficulty levels. So we make our way back to the portal, and we'll get there shortly, hopefully. And from there, we can go ahead and exit. And we are back to where we were. So now I'm going to head in an opposite direction, and you can see again there's that lag that shows that this is new data being stored. And we're going to go ahead and stop here in this snowy area so we can remember that. And now when we close the game and open up a new instance of it and load it, we should be right back in that snowy area. So we go back here, load the game, and here we are still in that snowy area. Now we're going to move back down to the dungeon, and you can see that there is none of that lagging, showing that this is data that has already been preloaded. So all of the different places that the user has experienced and explored already, that is being saved and then makes that loading process a lot easier. Now, as we get back to the dungeon, hopefully I can find it. Let's move back. Once we get back into the dungeon, the last thing to show is the death sequence. Here's the dungeon. So the user can go in and Oh, I forgot. One of the other things that dungeon progress is saved. So some of the enemies that I destroyed back there will not be there. So I actually had to go up here to one that I had not defeated. But this is, as you can see, even though every time things are randomized, the dungeon that we encountered before is going to be the same dungeon that we encounter here. And that allows for that persistence of data as well as persistence of progress, so that while each experience is unique and random, each instance of it, you're not going to, come across a completely different dungeon in a completely different location. So as the user dies, you can choose to respawn or go back to the main menu. And as you respawn, that data should still be persistent, and we're back where we started. So that is my game. Thank you so much for listening to the end and being a part of this. And if you would like to play the game, it is deployed at levineely.itch.io/procgen. So feel free to check that out. Thanks again and have a wonderful day.